Welcome. I think we're starting a couple minutes late to let stragglers come in, but I think that we can just get started, and then there'll always be a video. So first of all, I'll start out with introducing myself. I'm Joachim, one of the founders for Pelotech. Who's going to be presenting is Andrew today. He's one of the senior devs on the team. He's done a bang-up job on doing a lot of this work around the NGINX Ingress controller to the Envoy Gateway with Zero-Downtime. So that's what we'll be here. If you're expecting some other presentation, then you're probably in the wrong spot. Pelotech in general, we've done, and why we're also doing this is because we help a lot of clients. We work with a lot of Fortune 500 companies, government agencies in different parts of the world, as well as the U.S. government, the DoD, lots of different organizations. We tend to specialize a lot in cloud-native solutions, Kubernetes, high availability services, general organizational engineering, culture, and a bunch of other things as well. You can definitely check out our site for more info at pelotech.com. But that's the general gist on this. We decided to do this webinar mainly because, the NGINX Ingress controller is no longer supported and maintained. A lot of folks have been asking us, like, how do we migrate away from it? What can we do? And after going through this in a couple different, more than a couple different clusters, but definitely different clients, we figured we'd share this information out to anyone that would be intrigued and interested. For a little bit of housekeeping, if anybody has any questions, feel free to throw in the chat. Jenny will be keeping an eye out on the questions, and then we'll find like an appropriate place to interject. If it's like appropriate to do right there and then, she will. If it's at the end of the webinar, then she'll just post this or ask those questions there. And then afterwards, we'll open up also just a little bit more in just general Q&A, but feel free to just throw questions out as we're starting. And with all that said, then I'll hand it over to Andrew.
Hey, yeah, thanks for the intro. Definitely feel free to ask questions as we go. We'll have a chance to do that at the end as well. And this will be recorded, and I believe everybody who signed up will get an email with the recording. So just wanted to let everybody know about that. And yeah, I'm excited to be here and discuss this. This has been an interesting project. I've learned a lot, and I think have some valuable things to share with all the folks who have joined. So thanks for being here. Yeah, so this migration, we want to go over what the issue is with Ingress NGINX, why it's a liability to be running it today, how we've evaluated replacement controllers, the weighted DNS technique that allows for a zero downtime cutover, and what we found out in production that wasn't evident when we were doing it in our test clusters, among a lot of other things. And yeah, let's keep it going. So yeah, I guess I kind of went over a little bit about what we're going to cover, Ingress NGINX, why it's a liability today, a little bit about Gateway API, the successor API from Kubernetes, what changes, what is important about it, and what more expressive means, how we evaluated our options for replacement and why we chose Envoy Gateway, the zero downtime cutover, and some things about mutual TLS, request buffering, and multi-namespace complexity. Okay, yeah, so on Ingress NGINX, I believe it was in March of this year that either the last update shipped or they decided to announce the news that they're no longer supporting. The repository itself is actually archived, and there will be no future updates. So while it's served people really well, and we can definitely give a shout out to the maintainers for all their hard work on it, it won't be getting any updates. And that's not just feature updates, but that includes bug fixes and notably security patches. So I think that's one of the most sort of pressing issues that the end of life presents for people. And that's sort of what the top bullet here suggests, that new liabilities in the supply chain will not receive any patches. Any vulnerabilities that are discovered after this end of life is permanent unless you migrate, or unless you decide you want to patch the controller yourself, but that's a whole other undertaking. There's some compliance exposure issues that are related to this as well. So like if you're needing to comply with HIPAA, or PCI DSS around like credit card processing. Auditors will ask you about this, so that's related to the security, but sort of on a different dimension of it. And then just annotation debt. So the Ingress API expresses its routing through these sort of annotations. The Gateway API replaces them with the typed validated resource that are a bit less opaque, and in some cases are often vendor agnostic. So regardless of which controller you're using, they'll be relevant between different controllers, unlike some of the annotations that we saw in Ingress. Okay, so a little more on the Gateway API, where Kubernetes is heading. So it's not a drop-in swap. It's pretty significantly different. It's a richer specification that separates infrastructure concerns from application concerns. A little bit in that you have different classes. You have the Gateway class, which is the infrastructure provider where we're declaring capabilities, the actual gateway, where the cluster operator defines listeners, and then the HTTP route. This is where application teams it's designed for application teams to control that, defines routing, and generally this is where the Kubernetes project recommends you go. Even on their website, while Ingress is still maintained and obviously a lot of people are using it, their official recommendation is to move on to the Gateway API, and the Ingress API is sort of what they're calling feature frozen. So there will be changes to it. It may get like fixes and things like that, but we shouldn't expect that the actual specification will be offering new features in the future. So sticking on it, if it sort of presents a challenge if you want to evolve with the Kubernetes project, it's not going to provide that kind of avenue for you. And so yeah, Ingress, the kind of before to Gateways after, Ingress is one resource type where Gateway exposes 3 different kinds, and then additional ones for some of the kinds of extra configurations you can do. And again, yeah, routing is controlled through annotations, which are implementation specific or vendor specific, unvalidated, and generally cannot be shared across different controllers. So we evaluated 5 options, probably a little more if we're being honest, but we'll stick with kind of going over some of the 5 big ones that we ended up evaluating. So Envoy Gateway was our winner. So there's the Cloud Native Computing Foundation, that's CNCF. We tended to favor projects that they are supporting. It gives us a clear signal of like community support, and kind of we tend to favor tools that are community supported for long-term flexibility, and the CNCF is like a really good arbiter of kind of aggregating and supporting those kinds of projects. So we tended to favor projects like that, including Istio and I don't know if you pronounce it Higress. I'll pronounce it that way. Now Higress was an interesting one. It is CNCF recognized, but it's not in Kubernetes official Gateway API conformance results. I don't know if that's just a matter of them needing to catch up with it, but that was kind of maybe a signal of some of our concerns why we kept evaluating. Istio was really strong. It did a lot of what we needed, but was maybe a little bit more complex and awkward compared to Envoy Gateway. Traffic was an interesting controller. It offers pretty strong Ingress support as well as Gateway support, which made it pretty appealing for us. But ultimately, it's a very commercially driven project, and for the reasons I kind of spoke to, we were favoring community tools for flexibility. And then NGINX Gateway Fabric is not in the CNCF filter that we were looking on, and so we kind of ended up landing on Envoy Gateway, which also, yeah, met our needs around mutual TLS and buffering. Yeah, so like we said, we didn't just start by trying this out on the client cluster, and we didn't even start in our own cluster, or I guess we did in a way. We used Kind, which allows you to run locally, not on the cloud, and really what I would call fearlessly and rapidly experiment and iterate. We call it the disposable local cluster. So the stakes are really low. You're not getting the full cloud experience. There's no actual load balancers unless you use something like Metal LB. But you can test some of the most important stuff around the HTTP routes, those application level resources. So that was really important for us. And that was the place where we first evaluated the controllers, kind of saw what the APIs looked like, tested out the migration, so to speak, compared the options, and were able to evaluate and try things in a really low risk environment. Then once we felt comfortable with that, I mean, that did take some time. That was where, between the research of evaluating the controllers and then applying the actual configurations to the kind cluster, we spent a good amount of time there, and we're able to get really far. So this was super helpful for the evaluation and testing. But then once we felt like that was working well, we wanted to bring our findings and actually test it in a cloud environment. So we worked in our own cluster before we started with the client. So our strategy was to run both the Ingress and Gateway API simultaneously. This involves having a couple load balancers going at the same time. And we settled on a test application called Goldilocks. It basically is a web interface and service to scan your cluster and kind of check like resource utilization and things like that. What it actually does was unimportant. The reason we chose it, it's really simple to stand up. And the existing Helm charts support both the Gateway API and Ingress API. So it kind of provided an environment for us to really try this migration out in a way that was pretty easy. And we leveraged a controller we really like, ExternalDNS and cert-manager, which are both really important to how we tend to deliver our opinionated GitOps cloud setup foundation. And so those tools were in the picture as well and become pretty relevant during the evaluation. And we wanted to confirm that was working before we did anything else. Oh, also worth noting, we found an interesting tool called ING Switch. That tool actually scans a cluster, looks at the existing Ingress resources, and attempts to give you an automated, it's an automated way to kind of carve out a report that indicates, okay, what are you doing with Ingress today? What needs to be migrated? What annotations are you using? And can they be cleanly mapped from the Ingress API to the Gateway API? So we leverage that, running it both against our own cluster in the cloud and against kind to make sure that we didn't find any surprises. So that was a pretty powerful tool. Okay, so on to the dropping zero request piece. So when I first did the migration, we were able to get traffic moved from Ingress to Gateway, but there was a period of time when the DNS records hadn't caught up with the new HTTP routes, and so it was the TTL was basically still resolving to an address that no longer existed. We wanted to see how we could prevent that from happening. It's a matter of minutes. In some cases, depending upon when you do a migration, that can be an acceptable amount of planned downtime, but we're pretty interested in seeing if we could avoid that. So when you swap A records, there's a window where you might be resolving on the old TTL send request to the dead endpoint. And the duration really depends. I think if you run the dig command, you can see like how long till the next TTL window cycles, but you don't want to have to try and time it perfectly. So the solution we came up with was weighted DNS records. So it's a little similar to maybe the concept of round robin you may have heard of before, but in this case, you can actually specify a certain amount of weight to give to one versus the other. And the approach we took was to set up these weighted DNS records ahead of time for the existing Ingress routes and give them 100% of the weight. And then at the same time, deploy the HTTP routes for Gateway and give them 0% of the weight. And then once you confirm that all the HTTP routes are accepted in your Kubernetes cluster, that everything looks healthy, that the load balancers are stood up and everything is resolving correctly, you can actually shift that weight. And so it's kind of like almost a hot swap of sorts. And so you'll see here with the initial state, the Ingress resource. Oh, and notably, we use AWS supports this. I think probably any cloud provider supports this concept. And specifically, the external DNS controller we use in our Kubernetes clusters has an annotation-based way of expressing this. And so we're able to just say, for the Ingress resource, that it gets annotated with 100%, the HTTP root gets annotated with 0%, and then once everything is healthy, you just swap those. So there's no DNS records being created or deleted, you're just updating them. And the swap is like very real time, and all you have to do is change the weights. And if there are any issues, you can just roll back the value reversing. And so it makes the migration risk a lot lower and faster and more reliable. So this is just a little bit more about that. Again, the Ingress and HTTP resources are running in parallel under the same host name. And what we did was monitored via a shell script that pulled the endpoint and logged, but also did it with T. So I could watch in my terminal that it continued to loop on 200 statuses on the host name, and also wrote it to the file in case I didn't. In case it kind of like moved to the next page, I could still go back and review and make sure there were no dropped requests during that wait flipping. Here's a little bit about what internal testing surfaced. So one of the things we wanted to ensure we continued to support was mutual TLS with certificate forwarding. We were able to achieve that with Envoy Gateway. And again, the ING switch tool allowed us to scan the cluster, see that we were using, that we had mTLS cert forwarding needs with Ingress NGINX. It exposed that. It didn't automatically show us how we would do the equivalent in Envoy Gateway, but using that tool, we were able to recognize that that was one of the, there was like annotation parity that we needed to achieve, and that was one of the big requirements for us. So that tool surfaced that, and we were able to search through the Envoy Gateway API documentation and find the equivalent resources that's offered by that controller. Request buffer limiting is another one. Gateway API actually has the Gateway API actually has a native resource that's in experimental phase right now that expresses that, but there's a Envoy Gateway specific implementation that's available for now until the experimental API becomes kind of like mainstreamed. Again, that was found with the ING switch tool. And then finally, once we actually got to the client, we found out about the multi-namespace complexity. So prior to Gateway API 1.5, hostname definitions are required to be sort of duplicated at both the gateway, which is supposed to be a sort of cluster operator level concern, and the HTTP route, which is an application developer concern. This kind of violates the separation of concerns that the Gateway API was going for in the first place. So this was maybe a bit of a challenge that we didn't run into when we were working in our test cluster, because we weren't really in like a multi-tenant environment. But then working with the client, we realized that this was important. And while the duplication is, you know, a way to deal, this is the sort of the pain of dealing with the multi-namespace complexity isn't massive, but it is kind of unfortunate. But what we found out about was in Gateway API 1.5, they introduced this listener set concept, which allows application teams to define listeners with that kind of are not attached directly to the gateway. They reference it, so they're able to define new host names as they stand up new applications without needing to go through the gateway resource, which basically allows them to stand up new application instances that have new host names without needing to have a pull request reviewed by let's say their SRE team or whoever's operating their cluster. So this is pretty nice, something we hadn't anticipated in our test cluster phase, but that we were able to catch up with pretty quickly. And fortunately, Envoy Gateway 1.8 started supporting them right around the same time as we were doing this client engagement. So we were able to leverage those, and it allowed us to keep the separation of concerns really clean, which is nice. Okay, a few takeaways here. Evaluating against your specific production requirements. So the CNCF status that we've been looking for is a strong signal, but that's not alone enough. You really need to take into account what kind of specific needs your application has. In our case, that was mutual TLS buffering, and checking what annotations you're using today in Ingress versus what your production environment actually needs. Validating in a test environment is really important too. So every surprise we caught about the mutual TLS request buffering and the multi-namespace complexity, ideally you catch that before you do your production migration. And testing in a safe environment, starting with kind, moving on to a test cluster is what makes zero downtime possible. I think the weighted DNS concept was a real big unlock for us. That's the way to ensure that there is zero downtime. Running both controllers in parallel, you have a couple load balancers during that period of time, but you're able to do a really clean cutover. And you shift weights rather than swapping records, and it makes rollback really easy. And verifying through that through continuous polling gives you increased confidence there. And finally, staying current by migrating to the Gateway API and getting off of Ingress. It's how you stay compatible with where the Kubernetes API is going. Again, it's feature frozen. The Ingress API is feature frozen now. So moving over to the new API unlocks a lot of benefits in terms of what capabilities will be offered in the future, and staying up to date with tooling and improvements. All right, can open it up for questions now. Thanks for listening to me talk about this. I think it was a really cool project, and yeah, hopefully I could share some valuable insights with everyone.
Hi, Andrew.
Hello.
Yeah.
How's it going?
Yes, I have migrated my clusters to Ingress to Gateway API. So we have faced some 404 errors and some kind of 4xx errors, and go through the documentations and get to know about the backend traffic policy and the client traffic policies to match the Ingress annotations. And yeah, and also we doesn't follow this weighted round robin of DNS. We just created another cluster and we have two proxy layers. So Nginx VM upstream does the upstream to microservices. So we have done old cluster to new cluster. Yeah.
Okay, cool. So your approach was to stand up a new cluster with the Gateway API in favor of installing the Gateway controller in your existing cluster?
Yeah, that's in the existing cluster means I need to create that we have two ingresses defaultly, which will be internal VPC and external. So for external, I can able to use the weighted round robin of DNS, but for internal, I can use that. So we just created another cluster and migrated it.
Okay, nice. How was that? How did that approach turn out for you? Did you find that it was a pretty effective way of doing it, or any lessons learned?
Yeah, definitely checking the logs and getting also the Envoy proxy we need injected in gateway to get the JSON output of logs is very useful for us.
Nice, very cool.
Yeah, thank you. Thank you for your session.
Absolutely. Thanks for joining us. And I'm glad that it went well for you. And yeah, there's definitely a lot of different approaches to solving this problem. And yeah, we like what results we got, but it's also very interesting to hear how other people tackled the issue. One thing I meant to mention and chat with Joachim about during the presentation, we went into a little bit about security vulnerabilities as it relates to NGINX. And I know for me, this has been a really interesting one because when we put this presentation, this webinar together, and I was writing a blog post about it, we were speculating about potential new security issues that might come out and affect NGINX. And what we saw, I think just a few weeks ago, was a new vulnerability. I don't know if it's specifically in like the spec, we'll say, of HTTP2, but it was discovered across several different applications, that being NGINX itself, Apache Tomcat, I believe, and Envoy. And so Envoy and well, all of these were able to patch, but for NGINX, for Ingress NGINX, the controller, it's running on one of these old versions of NGINX itself. So we're kind of seeing that, and it was discovered by Codex, I believe. So it was an LLM discovered security vulnerability. And so I think we're going to start to, we've already seen a really large volume of vulnerabilities been reported now that we're in the AI era. And I think we can expect to see a lot more of that. And I meant to kind of chat with you, Joachim, about your thoughts on that and how it kind of affects the future of software development and security problems.
Yeah, I mean, in general, I think that's always going to be it's, how would I say, security and vulnerability issues and everything that comes up is always like been an issue, but with LLMs and everything that's going on, it's just going to be just more important to like get them plugged faster. And I think that the entire premise that we've had as a group and just as a company in general is the volume of how quickly we can introduce changes or improvements into functioning production workloads in general. So that's not just code, also infrastructural changes and things to that nature. So usually when we work, and at least my view on is whenever I'm setting up clusters or working in new projects, is how quickly can we introduce a change throughout the entire pipeline so that you can address and patch these. So I mean, that includes being like not being on old software, not old software, but like unmaintained software. So if NGINX controller now is no longer reaching, like having maintained issues, now we run the issue that even if we said, hey, let's fork this, let's do a quick patch update and whatever, that's totally doable. You could totally say, hey, let's patch it, let's do our own forked version of it and deploy it. But now the cycle time that it takes to get that patch out is going to be massively larger. So I think just in general, it just doubles down on the issue of how do we keep things as up to date as quickly as possible, but the as quickly as possible being ultra important. So that's a lot of the clients, especially when we have ones that like severe security issues or security requirements from teams, we end up spending a lot of time with those teams to say, hey, how can you, for example, instead of turning security groups as a gateway and saying, hey, and gatekeeper saying, hey, we don't allow this to go through because of X, Y, and Z. How do we work with them to say, hey, you enable to have both security and increased speed, not have it be one or the other. So that includes anything from software, infrastructure, introducing changes. But the slower you introduce changes into the system, the less secure it makes it, especially when there's deals or things like this that are coming out all the time now.
Yeah,
so at least that's my take on it.
Quickly. Yeah, no, absolutely. Yeah, you need to be able to respond quickly. You need to be poised for that kind of agility, because it's a you need to be able to get the patches quickly. The longer you're insecure, the more vulnerable you are. So yeah, I think being able to respond quickly is huge.
Yeah, the premise that I would say there, though, is it's very easy to say, oh, when there's a security issue, we'll be fast when there's security issues, but we won't be fast for other things. I would just cautious to say that. It's like you want to be able to really measure the speed of when you start any change, whether it be a security, whether it be a software feature, whether it be an infrastructure update, whatever it is that you're doing, any kind of change, I would say treat it the same. From the moment that you establish saying we want X to happen, how quickly did that actually go through all the way to production, and not, oh, And it's also one of the things I've seen teams do a lot is like, oh, well, my part's done. That's all it took. And the focus really being on getting to the end spot. So even if you say, oh, well, the security audits only took X amount of time. Well, that's X amount of time in addition to every other X amount of time. So really measuring the ultimate start to finish cycle time, I think is the only thing that really, really matters, especially in this kind of world.
Yeah, no, definitely. I think general speed to act across infrastructure, application updates, security concerns, the faster you can respond to stuff and get things from start to finish, the better, for sure.
Yeah. And I'd say that that's also like why we tend to lean heavily on not manually doing things in clusters, not like having a very like GitOps, like everything is automated. Anytime that we don't have something automated, it's the next piece is automated. There's also, I think I've talked to you about this before, but one of the talks I really like is the Simple Made Easy talk by Rich Hickey that talks about like just systems design in general, that it's really hard to create simple systems that are easy to understand. And it's very easy to create complex systems that are hard to understand. And so I think we strive to try to create simple systems that drive the ability to continuously be able to drive those kind of changes rapidly because they're a lot easier to change. So it means that we probably take a little bit more time up front in how to create those systems up front and how to keep evolving them in a way that's continuously simpler, but that drives the ability to continuously get faster and introduce changes into the system faster, which then allows us to apply security issues faster and software updates and product value and all the the other things that come along with it.
Yeah, definitely. I like it.
Cool.
We have any other questions from our guests and participants?
Going once, going twice. Well, if there's no other questions, feel free to reach out. I mean, there's obviously the emails on the screen here that can go on there. Oh, that's funny. My email's not on there. So I guess you can reach everyone except me. So like, feel free to reach out, and we're more than happy to ever talk about or geek out about any of this kind of stuff.
Yeah, absolutely. We appreciate y'all being here. Definitely hit our emails up. Appreciate everybody joining, and yeah, have a great day, everyone.
Oh, wait,
wait. Yeah, then maybe we gotta wait a moment here. Do we have a raised hand or another question? Is that?
It was an accidental raised hand. Maybe it was an I'm leaving.
And I was looking a wave goodbye. Yeah.
Yeah, wave goodbye then. Okay.
All right, cool. Thanks everybody. Take care.
Thank you.
Bye.